Pairing wind sensors with UAVs produces a more maneuverable, reusable, and lower-cost data collection system compared to traditional tower installation or balloon deployment. But how to bring these technologies together? There is not one right answer. Your solution will vary depending on your intended use and the characteristics of your chosen UAV. But all systems must address the two major challenges. 1. Staying in the air long enough to get good measurements. And 2. Accessing actual air rather than UAV effects. Staying in the air requires sensors that are compact, lightweight, and low power, such as the TriSonica Mini, which weighs less than 60 grams, or the TriSonica Sphere, which weighs less than 225 grams. Staying in the air also means that the boom or mast to which the sensor is attached must be lightweight, resist vibration, and preserve flight balance of the UAV, such as a carbon fiber tube. That boom or mast is necessary to access actual air. That is, to position the wind sensor where it can measure ambient wind, rather than movement created by the body or aerodynamics of the UAV itself. For a fixed-wing UAV, this might be a boom extending from the nose of the aircraft. For multi-rotor UAVs, this might be a single mast centered above the body of the aircraft, or one or two booms extending out the side along a center line from the body of the aircraft, furthest from the downwash of the rotors. Of course, the question arises, how long should that boom or mast be? Well, the boom or mast should place the sensor in a zone of low interference. That is, minimal wind induced by the UAV. The location of that zone of low interference will vary according to the body characteristics of the aircraft, the dimensional size of the aircraft's rotors, and how fast the rotors are moving when in use. This zone can be identified in your specific case in several ways. Direct visualization of UAV performance at load in a smoke or fog chamber, direct measurement with a calibrated anemometer at various distances from the UAV, or by computational fluid dynamics modeling. As a starting point, we have received reports that the zone of low interference is likely to be found at a distance from the rotor that is at least greater than 1.5 times the diameter of the UAV rotor. Finally, experience has shown that if very fine air movement detection is desired, the UAV should hover in place for several seconds to allow ambient air to return to normal before sampling. The information in this video is a simplified introduction to sensor placement on UAV for optimal functionality, and is based on the published work of several researchers. We invite you to check out the original papers, including the practical tests they used, the mathematical equations they found for adjusting for the UAV motion in collected data, and other key interpretive calculations. Thank you.